Hello, everybody. My name is Robert Ivey from GCA Technology Services, and today we're going to talk about enabling your workforce to work remotely while reducing costs by removing things that are unneeded, such as VPNs for every user in your organization. Currently, GCA, we did a case study where we have an application that I have running out in the Amazon cloud. Now, for the purposes of this explanation, this can be in the Amazon cloud, it can be in the Azure cloud, it can be in virtually any cloud you can think of, or it can even be on premise in your own data center. What we're doing here is we have a traditional two-tier application where we have a web server with its backend database. The web server and the backend database are in a situation where you don't want threat actors to be able to have access to them because they have sensitive data. So typically organizations opt not to put these out on the open internet because you would allow any threat actor anywhere in the world to be able to access them. What we've done is we've exposed this application out to the internet in a secure way. The way that we secure it is by using something called an IAP, or an identity aware proxy. What this does is it forces authentication of any user who wants to attempt to connect to our application prior to any of their connectivity being able to talk to the server. This prevents any of the application's vulnerabilities from being exposed on the internet. The reason why this occurs is because we force authentication to happen first. Now, in a traditional two-tier application, if we were to expose it to the internet, you would start at the end user over on the far left. You would follow a line to come in through the firewall, and then the traffic comes in. Now, without this middle piece in place, the traffic would go straight to the web server. With the traffic going straight to the web server, any threat actor can now try to attack any vulnerabilities in the application in order to steal the data in the database. So the IAP, which is the item that we've added in this case, it's in Amazon Cloud, so the IAP is an AWS application load balancer. What we do with the AWS application load balancer is we force an authentication with AWS single sign-on using Cognito services. At GCA, we don't use Cognito services for our single sign-on tool of choice, but if you're an organization that does, at that point, you're done. If you're not, AWS single sign-on will actually redirect to your own identity provider. Most organizations have more than one identity provider in their environment, whether they're aware of it or not. Examples of identity providers that can be used to support this are, and there's quite a few of them here, but you can use identity providers such as Okta, Ping Identity. You can use Microsoft Azure Active Directory. You can use on-premise products such as IBM, Oracle Access Manager, ForgeRock Open Access Manager, NetIQ Access Manager, and there's a litany of others. You can also use cloud services such as Amazon Cognito, which we were using here as part of the integration, and various others. If your application is actually running on-premise, you don't need the AWS application load balancer. You can use a tool such as an F5 or a NetScaler, or if you have some of the next-gen firewalls, they have some of this functionality as well. So let's take a look at what the end user experience is when we go through this. So when the end user tries to go to their application, typically you would expect it to land on the application screen. But in this case, it actually jumps us over to our identity provider. No user is allowed to access this application until they've successfully authenticated. Now at GCA, we use an identity provider, which you're seeing my login screen here, and we have policies that require very strong authentication mechanisms. So in this case, I'm using a security key, which is a hardware token, such as a YubiKey, in order to authenticate my request. Once I've authenticated my request, my traffic is then allowed to pass through the application load balancer. Now keep in mind, that doesn't have to be an AWS load balancer. That could be a NetScaler. That can be an F5, whatever you may have already. We can leverage that. And now my traffic is actually able to pass through into the application itself. Now, this is a dev sandbox of one of my applications that I have, which is why you see the red text that it's under maintenance. And in production, we actually have it single signing the user all the way into the application. But I wanted it to stop here to show you that in this case, the application doesn't even have to be logged in. All we're enforcing the authentication for in a zero trust methodology is we want to ensure you are who you say you are and you are an authorized, authenticated user for my application before we ever let you talk to the web application. Moving back over to my diagram. What we've allowed in this configuration is the capability for you to no longer require the purchase of VPN licenses for all of your users. In this case, it's actually more secure than a VPN. The reason why it's more secure than a VPN is if you're in a VPN-like environment, you're actually taking the user's entire machine and bringing it into the network. In this case, we are only allowing one browser session instance to have access over one port to access one application within my network. I've greatly reduced the footprint that the end user's machine is allowed to talk to in my environment. So if you have an environment such as BYOD devices where you're nervous about passing out VPNs and having them install it, this is a agentless, no install required, and it can be done on any device as long as it can pass your authentication at your identity provider. If you wanted to enforce things such as antivirus policies or no BYOD policies, that can be done at the identity provider where it checks the machine prior to allowing the authentication to succeed. How can GCA help you with this? Whatever tools you already have, whether you're a Microsoft Office 365 shop that has Azure Active Directory as your identity provider, or maybe you're an Okta shop or a Ping shop. Whatever identity provider you have, GCA can help show you how to hook your identity provider up in this configuration. The other piece of this configuration uses another tool that you probably already have. You probably already have some form of an application load balancer. Many organizations use things such as NetScaler or F5s in order to provide that type of functionality. What this configuration does is takes two tools such as that, your identity provider and your application load balancer. It then takes them and has them work in conjunction in order to create a more secure than VPN, much more flexible than VPN way for your remote users to access their resources. And the best part about it is because we're using tools that you already have, all we have to do is configure it, and we can save the cost of buying VPN licenses for all of those users that simply need VPN access so they can access one or two applications that you just haven't enabled to be externally available yet. For more information on this, look up BeyondCorp. That is Google's example of how to set up a zero trust architecture. This follows all of the zero trust principles in order to ensure that your applications, even while exposed to the external internet, are very secure using zero trust concepts. Thank you.